Okay, hi and welcome to anyone that's watching this video. The purpose of today's video is to go over the quadratic discriminant and what that actually helps you find when it comes to quadratic equations. So the formula for the quadratic discriminant is listed here, b squared minus 4ac. But what does that actually tell you? This tells you how many solutions there are to a particular quadratic equation. And when I say solutions, I'm talking about how many x-intercepts. Does it cut the x-axis once, twice, or no times at all? And they're all the possible options for a quadratic equation. You can have up to 2 x-intercepts. So the quadratic discriminant formula comes from the quadratic equation, and it's written underneath the square root sign. That might give you a little bit of insight as to what the particular solutions to this are allowed and not allowed. For example, for a square root sign, if you take the square root of a negative number, it can't be done in this case. So we can only really think about positive or zero solutions to the discriminant. But we can still get negative ones, and that still tells us something about something very important about the quadratic formula or equations that we're looking at. So the three possible options is that when we solve this discriminant formula, we can have a solution greater than 0, and that means that we have 2 x-intercepts. We can have the solution equaling 0, and that means we have 1 x-intercept. We can have the solution being less than 0, so a negative number, and that means that we have no x-intercepts. And just recapping, the a's and the b's and the c's that come from the discriminant formula and the quadratic formula are just whatever the a, b, and c are in the quadratic equation in question. So we just take those numbers and put them into the formulas and see what we get. Just to visually represent it, I've got 3 different graphs here showing what the different number of solutions look like. So when we say 2 solutions, we mean it crosses the x-axis twice, like this. When we say 1 solution, it means we cross the x-axis once, we just touch it, like this. And if we have no x-intercepts or no x solutions, it means the graph never touches the x-axis, like this. And you can see my quadratic, my discriminant representations down here. So it's really just a simple matter of putting the numbers into the discriminant formula. So for this equation here, we want to know how many x-intercepts there are. So I'll take the discriminant formula, b squared minus 4ac. And remember that this is a, this is b, and this is c. There is secretly a 1 there. So b squared is 9 squared minus 4 times a, which is 1, times c, which is negative 10. And yes, the negative has to come along with it. So 9 squared is 81 minus 4. We have to be careful with the brackets and the negatives and all these sorts of things. You can also type it in your calculator, but again, you've got to be careful with the brackets and the negatives. So negative 10 times 1 is negative 10. So that leaves us with 81 minus 4 times negative 10. So negative 10 times 4 gives us negative 40, but it becomes a plus 40 because of the negative and a negative. So 81 plus 40 is 121. So it doesn't matter particularly what the exact number is. What matters is that this is a positive number. And that means that this discriminant is greater than 0. And that means that there are two x-intercepts for this equation. Let's do another example. 2x squared plus 3x plus 8. We will take whatever our values for A, B, and C are, and we'll put them into the discriminant formula. So B is 3. That's 3 squared minus 4 times A, which is 2. C, which is 8. 3 squared is 9 minus 4. Well, I'll do the brackets first. 2 times 8, which is 16. And then 9 minus 4 times 16 gives me an answer of 64. And we can see that this is going to become a negative number, definitely. So 9 minus 64 gives us negative 55. What's important here is the fact that this is a negative number. So that tells us that the discriminant is less than 0. And that means there are no solutions, no x-intercepts, in other words. So it does not touch the x-axis, this quadratic equation, this parabola. The third example I have here is a little different. The quadratic equation we have is missing values. So we don't know what those values are, k, x squared minus 3x plus k. But we need a little bit of extra information to know what happens with this quadratic equation. And we're told that there is only one solution for this quadratic equation. So think, if there is only one solution, that means the discriminant is equal to 0. So something we can say about this formula, about this equation, is that b squared minus 4ac has to be equal to 0. So we'll just treat it like any other quadratic equation, any other discriminant formula, and put the numbers in. So b is negative 3, the negative has to come, minus 4 times a, that is a k, but it doesn't matter what it is, you just put it there. C is also a k, so put it there as well. So if we clean this up a little bit, we've got negative 3 times negative 3, which is positive 9, minus 4, and k times k is k squared. What that leaves us with is just an algebraic equation where we need to solve for k. And that's what the question asked. It said, find k if da 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 da. So this is not too bad. So we'll rearrange this for k. We'll take the 9 over the other side. That should be a negative 9. And we've got a negative on both sides. So that means we can divide through by negative 1, making the whole equation positive. Trying to get k by itself, we'll divide through by 4. And k, if we take the square root of 9 over 4, okay, this will be our solution for k, except we just have to quickly remember that when we take the square root, there are two possible answers, positive and a negative of that. So the square root of 9 over 4 is equal to equal to the square root of 9 divided by the square root of 4, which is 3 over 2. We will have a positive value of that. And we will have a negative value of that. So there are two possible values of k for this quadratic equation that gives us one solution, meaning giving us one x-intercept for that equation. So this might seem a little strange. What does this actually look like? It means there are two different graphs that satisfy these conditions. And I have graphed this over here, just so it makes a little bit more sense. So for those values of k, it was 3 over 2 and negative 3 over 2. The red parabola here is if we consider k to be positive 3 over 2. That's what it looks like. If we consider k to be negative 3 over 2, the blue parabola is what it looks like. And you can see both of those only have one x-intercept, just touching the x-axis. Anyway, I'm going to end the video there. I hope things make a little more sense after that, and thank you for watching the video.